Hey class, welcome back to the unit on area of polygons. Today we're going to talk about comparing the perimeter and area of similar figures. Now this one's probably going to be, again, 3 videos. And what we're going to focus on the first one is basically finding ratios and finding area. Because this is going to be a little bit new and hopefully you'll understand it as we go along. So I'm going to jump in with a little activity. Okay, so not that. So here's a little activity. I'm going to start with a few different rectangles, and we're going to compare things to see how they go. Okay, so here we have our first rectangle. As you can see, it's 5 by 3, and what we want to do is figure out, well, what is the perimeter of that thing, and then what is the area of that thing. And so the perimeter of this rectangle is found by adding up all the sides, right? So 5 plus 5 and 3 plus 3. So we have 10 and 6. The perimeter is going to be 16 units. Okay, so we know the perimeter of that rectangle is 16 units, and we know that the ratio of the scale, or the ratio of the sides is 5 to 3. Perimeter 16. Now what about the area? Okay, so the area of that rectangle is going to be found by multiplying 5 and 3, and we're going to get 15. Okay, so our area is 15 square units. Okay, so 15 square units. I'll call it units squared. All right, so the original relationship, 5 to 3. Okay, so the original relationship, 5 to 3, was our scale. The perimeter was 16, and the area is 15 units squared. So here's my question. What's going to happen if we increase the dimensions of that rectangle by a scale factor of 2 to 1? Okay, so if we increase that rectangle by a scale factor of 2 to 1, what's going to happen? Well, our length from 5 is going to now be 10, and our width from 3 is going to now be 6. Okay, so we now have 10 to 6. Okay, so remember the scale factor was 2 to 1. The scale factor was 2 to 1. What now will be the perimeter of this rectangle when we add up all 4 sides? We have 10 and 10, which is 20, and 6 and 6, which is 12. 20 and 12, of course, being 32. And we have our area. Okay, our area, 10 times 6, would be 60 square units. Okay, 60 units squared. Now, here is my question. We have a new thing now. We've known what scale factor was. This is what just happened. Now we're going to talk about something called a perimeter ratio. What is the ratio of these two perimeters? And we'll find out. Okay, so the ratio of these two perimeters, we have the second perimeter, the bigger perimeter, was 32. The original perimeter was 16. So the perimeter ratio was 32 to 16. Or also, 32 divided by 16 is 2. The perimeter ratio was 2 to 1. Now, here's something interesting. The perimeter ratio was 2 to 1. What was the scale factor? 2 to 1. Isn't that weird? So if we grew each dimension by a scale factor of 2, the perimeter ratio, when we compare the two perimeters, is also the same. That is a neat thing to consider. Let's figure out what's going to happen with the area ratio now. Okay, so we look at the area ratio here and the original area ratio. So we have 60 square units was our bigger area, and the original area was 15 square units. And if we simplify that, that's going to give us an area ratio of 4 to 1. Isn't that neat? So we're going to think about some stuff here. Scale factor that we grew the dimensions by was 2 to 1. The perimeter ratio was 2 to 1. And the area ratio, 4 to 1. Let's think about that for a second. Let's do another activity now, or keep going with the activity. What if we grow from the original rectangle to a larger rectangle, but each dimension by a scale factor of 3 to 1? Okay, so let's see what's going to happen. from 3 to 1. Our original length was 5. Well, now for 3 to 1 is going to be 15. And our original width was 3, but now if we're going to grow that by a scale factor of 3 to 1, it's going to be 9. So the ratio of our sides, of course, is 15 to 9. The scale factor, 3 to 1, what is the perimeter going to be? Okay, so let's take a look at the perimeter now. 15 and 15 is 30. 9 and 9 is 18. 30 and 18 is 48. So now the new perimeter is 48, and the new area is 15 times 9, or 135 square units. So this is our new area now, right? So the new perimeter, the big thing is 48, and the new area of the big thing is 135. So let's take a look at how that's going to impact perimeter ratio. So remember, we grew by a scale factor of 3 to 1. How does that impact the perimeter? Well, the new perimeter is now 48. The original perimeter was 16. So our perimeter ratio, 48 to 16, guess what? Same as the scale factor, because 48 divided by 16 is 3. 3 to 1. Now the question is this: what do you think will happen with the area? Okay, so the area ratio, now we're going to compare the two areas. The new area was 135 units, square units. The original area was 15 square units. So how is that going to compare? So 135 to 15. Did you know that 135 divided by 15 is a number? And that number is 9. So the area ratio is 9 to 1. So what is happening here as we grow similar figures, right? We're growing similar figures, and we see their scale factor. We can compare their perimeters. Their perimeter ratios have an interesting relationship with their scale factors, don't you think? And their area ratios have an interesting comparison to their scale factors as well. Which brings us to our note. And there's only one. When we talk about perimeter and area of similar figures, if the scale factor of two similar figures is A to B, then the ratio of their perimeters is A to B, and the ratio of their areas is A squared to B squared. Let's see if you picked up on that. If the scale factor is 2 to 1, the perimeter ratio, the same. The area ratio, 2 squared to 1 squared. If the scale factor was 3 to 1, the perimeter ratio was the same, and the area ratio, 3 squared to 1 squared. So that is what this note actually means. And the way I'll be working with this in the examples is if we have a scale, and let's say this scale is, we'll grow something, let's say 5 to 3. That means we'll have a perimeter ratio. The perimeter ratio would be the same, 5 to 3, and the area ratio will not be the same. The area ratio will actually be 5 squared to 3 squared, or 25 to 9. Okay, so that's what I'll be showing in our examples. So let's take a look. We're going to do a couple examples and then call it a day. Let's see how ratios work. So we're going to be finding ratios. And here, this is the first problem. We have two similar polygons. Remember, all this is dealing with similarity. Two similar polygons, same shape. Same shape. So two similar polygons have corresponding sides in the ratio of 5 to 7. Okay? So that's basically our scale, 5 to 7. The question is, what is the ratio, larger to smaller, of their perimeters? Okay, so we have, this is a neat trick, see if you can figure out the answer. We have our scale factor, basically 5 to 7. So we know the corresponding sides are the ratio of 5 to 7. So what is now the ratio of their perimeters? The perimeter ratio is going to be the same. So this is our scale. Scale factor is 5 to 7. The perimeter ratio is going to be the same as we just discussed. which is 5 to 7. So you might be thinking that our answer is 5 to 7, but it is not. We have to be careful and read. What is the ratio? Larger to smaller of their perimeters. So we have to say it's actually 7 to 5 or 7 to 5. That is the ratio of the perimeters. So I use this example to help us read carefully and figure out how ratios work, right? We say 5 to 7, we could say 5 to 7, but it's asking for larger to smaller, so we would say 7 to 5 or 7 to 5. Okay, so we're going to keep that in mind as we go through another example. So here's our last one. We're going to have two similar trapezoids, and the ratio of corresponding sides is 6 to 9 or 2 to 3. So our scale, the scale factor that we're dealing with, we're going from 6 to 9, okay, or 2 to 3. So what does that mean for our perimeter ratio? Okay, so remember, perimeter ratio stays the same. So our perimeter ratio is going to be the same, 2 to 3. Okay, so when the question is asking, what is the ratio smaller to larger of the perimeters, we know that 2 to 3, 2 is smaller, so we'd say 2 to 3. And that is the perimeter ratio, or the ratio of the perimeters, 2 to 3, smaller or larger. Now the next question is, what is the ratio of their areas? Okay, so if we have our scale ratio, which is 2 to 3, then the area ratio, remember the note. Remember the note. If the scale factor is a to b, the area ratio is a squared to b squared. Okay, so if our scale factor is 2 to 3, the area ratio is going to be 2 squared to 3 squared, also known as 4 to 9. And that is our area ratio. So we have to be careful now. It's saying smaller to larger. It was 4 to 9, so we're going to call it 4 to 9. And that is where I'm going to end the video for today. The nice little introduction to what we're doing with similar figures and areas and perimeters. And we'll continue with the second video to learn more. Bye.